Ever wonder if space rocks follow traffic rules? Our solar system's asteroids move in surprisingly organized patterns, like cars on a cosmic highway. Today, we'll explore how these space rocks navigate their celestial routes through our solar neighborhood. Let's explore how asteroids actually move through space. Most asteroids in our solar system follow regular, predictable paths around the Sun, much like planets do. They're guided by two main forces: the Sun's gravity pulling them inward, and their own forward motion trying to carry them straight ahead. This creates what we call an elliptical orbit. Imagine a slightly squashed circle. The main asteroid belt, located between Mars and Jupiter, is like a cosmic highway where millions of asteroids travel in their own lanes. These space rocks complete one orbit around the Sun in about 3 to 6 years, depending on how far they are from our star. While it might look chaotic from Earth, these asteroids are actually following well-defined paths that scientists can track and predict with amazing accuracy. Let's talk about a fascinating pattern in the asteroid belt called Kirkwood gaps. Think of them as empty lanes on our cosmic highway. These gaps aren't random. They're special zones where you'll find very few asteroids. They exist because of Jupiter's powerful gravitational influence. When asteroids try to orbit in these areas, Jupiter's gravity acts like a cosmic tow truck, pulling them into different paths. It's similar to how a big truck on the highway creates wind patterns that push smaller cars away. These gaps were first noticed by Daniel Kirkwood in 1866, and they help us understand how planets can shape the space around them. The amazing thing is that these gaps have stayed mostly empty for billions of years, showing us just how strong and lasting Jupiter's influence really is. Now let's meet the biggest traffic officer in our solar system, Jupiter. This giant planet acts like a cosmic police officer, using its massive gravitational pull to keep asteroids in line. Jupiter is so big that its gravity can change the path of asteroids thousands of miles away. Sometimes it protects Earth by pulling dangerous asteroids away from us, like a helpful crossing guard. But it can also send asteroids toward the inner solar system, much like a traffic cop redirecting vehicles. Jupiter's influence is so strong that it doesn't just affect individual asteroids, it helps shape the entire asteroid belt. Without Jupiter's presence, our asteroid belt would look completely different, and Earth might face many more asteroid visitors. This shows us how one planet can help keep our cosmic neighborhood organized and relatively safe. Now let's see why most asteroids are content staying in the main belt, like well-behaved drivers sticking to their lanes. The main asteroid belt is actually a pretty stable neighborhood, kept in check by the balance forces of the Sun and Jupiter. Most asteroids here orbit between Mars and Jupiter at distances of about 200 to 300 million miles from the Sun. Think of it as a cosmic sweet spot. If asteroids try to move closer to the Sun, Jupiter's gravity pulls them back. If they drift too far out, the Sun's gravity reels them in. This balance creates a natural zone where asteroids can orbit peacefully for millions of years. The asteroids also help keep each other in line through their combined gravitational effects, like cars naturally spacing themselves out on a highway. Let's look at something cool: asteroid families. These are groups of asteroids that travel together through space, like cars in a convoy. They're actually pieces of larger asteroids that broke apart after collisions millions of years ago. Each family member shares similar features. They move at about the same speed, follow similar paths, and are made of the same types of rocks and metals. The largest asteroid family we know comes from an asteroid called Themis, with over 4,000 pieces. Scientists can trace these families back to their parent asteroid by studying how they move and what they're made of. It's like cosmic detective work, helping us understand how asteroids break apart and spread through space. Now let's look at the rebels of our cosmic highway, near-Earth objects or NEOs. These are the asteroids that don't follow the usual rules and venture closer to Earth than their main belt cousins. Most of these space rocks were pushed out of their normal orbits by collisions or Jupiter's gravity. They're like cars that took a wrong exit and ended up on a different road. Some of these asteroids cross Earth's orbit, which is why scientists keep such a close eye on them. While this might sound scary, we're actually really good at spotting and tracking these cosmic wanderers. Today, we can detect NEOs when they're still millions of miles away, giving us plenty of time to calculate their paths and make sure they won't cause any problems for Earth. Let's explore one of the most fascinating aspects of asteroid movement: orbital resonance. Think of it like a cosmic dance where asteroids move in time with the planet's orbits. When an asteroid completes 2 orbits in the exact time Jupiter makes 1 orbit, we call this a 2.1 resonance. It's like 2 dancers moving to the same beat, just at different speeds. This rhythm can either protect asteroids, keeping them in stable orbits, or push them away from certain areas, creating those Kirkwood gaps we talked about earlier. The really cool part is that these resonances work like a natural sorting system, helping organize our solar system into the orderly arrangement we see today. Some asteroids even get caught in special resonance patterns that protect them from being thrown off course by Jupiter's massive gravity. Let's check out one of the coolest groups of asteroids in our solar system, Jupiter's Trojans. These asteroids have found perfect parking spots around Jupiter, hanging out in 2 special areas called Lagrange points. Think of these spots as cosmic sweet spots where Jupiter's gravity and the Sun's pull balance perfectly. There are 2 main groups of Trojans. One group travels ahead of Jupiter, while the other follows behind, like a well-organized space carpool. Each group contains thousands of asteroids, all moving together in a stable pattern that's lasted for billions of years. What's really neat is that these asteroids are probably leftovers from when our solar system first formed, making them like time capsules from our cosmic past. Beyond the main asteroid belt lies a different kind of space highway, the Kuiper belt. This region, starting past Neptune, follows its own unique traffic rules. Instead of rocky asteroids, we find icy objects called Kuiper belt objects, or KBOs. These space snowballs are much bigger than typical asteroids, with some being as large as small planets. They move more slowly than main belt asteroids because they're so far from the Sun. It can take hundreds of years for them to complete just 1 orbit. The Kuiper belt is also much wider and more spread out than the main asteroid belt, like a cosmic highway that's been stretched to many times its normal width. Pluto, once considered our 9th planet, is actually one of the largest members of this icy highway patrol. Let's explore what happens when our cosmic highways get a bit too crowded. When asteroids bump into each other, it's like a slow-motion traffic accident in space. These collisions happen at speeds of about 11,000 miles per hour, way faster than any car crash. When asteroids collide, they can break into smaller pieces, creating new asteroid families. Sometimes these collisions send debris flying in new directions, like cars taking detours after a traffic jam. The pieces can end up anywhere. Some stay in the main belt, while others might get pushed toward Earth or even ejected into deep space. These space crashes have been reshaping our solar system for billions of years, creating the complex network of asteroid paths we see today. Thanks for joining me on this cosmic journey through our solar system's amazing asteroid highways. If you enjoyed learning about space's traffic rules, hit that like button and subscribe for more space adventures. Share with your fellow astronomy fans.